let me introduce our case study. Cycling is a common activity in daily life. However, cyclists often notice that riding uphill requires more effort than riding downhill. This case study investigates the mechanics involved in cycling on slopes. Our purpose of study is to understand how force affects bicycle motion in different slopes.
Do you guys notice that cycling uphill requires massive effort while cycling downhill requires almost none? This video will explore the mechanical reason behind this contrast. So before we showing this video, let me explain the objective behind this case study.
There are three objectives of our case study. First, to analyze the force acting on bicycle. Second, calculate the force required when cycling uphill. And third, to compare the effort needed for uphill and downhill cycling.
Based on the video, we clearly see that a cyclist needs more effort for going uphill compared to downhill. So to confirm this theory, let's move to a question. The question is, a bicyclist is going up a 5% slope by a uniform speed of 27 km per hour. The magnitude to the air resistance force is given by force resistance equal to kV square, where the numerical value of k is equal to 0.3. If the unit of the speed is meter per second and the unit of the resistance force is the Newton, the mass of the bicyclist including the bike is 70 kg. Do not consider the rolling resistance. For first question is, what forward force exerted on the bike by the road is needed to make the bicyclist move with constant speed? Next question, how much the work does the bicyclist do when riding a distance of 1,200 meters? What is the power of the bicyclist during the ride? Assume there is no loss of mechanical energy.
In question 1, we need to find the total forward force needed to keep a bicyclist moving uphill at a constant speed. Because the bicyclist is moving at a constant speed, the net force is 0. This means the forward force must perfectly balance out two opposite forces, which is air resistance and covenant of gravity pulling them over here. Before calculating the force, we need to make sure our baseline numbers are in the correct state. First, we need to convert the speed. The program gives us a speed of 27 km per hour. To convert this into meter per second, we will divide by the conversion factor 3.6. This gives us a uniform velocity of 7.5 meters per second. Next, look at the slope. We are dealing with 5% slope. Mathematically, a 5% slope means a rise of 5 units for every 10 units horizontally. For small angle like this, the sign of angle is practically identical to the gradient. So, we can directly use sin theta equal to 0.05. Next, we will calculate the air resistance using the given formula. We will substitute the given constant k equal to 0.3 and our converted velocity, which is v equal to 7.5 meters per second, into the formula. So, we will get the answer that air resistance is pushing against the rider with a force of 16.875 newtons. Now, we figure out how hard the gravity is pulling the cyclist backward down the incline. The formula for the component of weight parallel to a slope is Fg equal to mg sin theta. M is for the mass, G for the gravity, and sin theta for our slope factor. After substituting all the information that we get in the previous statement into the equation, we will get that value of gravitational resistance is 347.3 newtons. Next, we need to find the total forward force. To maintain a constant speed without accelerating or slowing down, the bike's forward force must exactly equal to the sum of both opposing forces. So we will add the Fg and the Frs to get the total forward force. So 34.3 newtons by 16.875 newtons equal to 51.175 newtons. In conclusion, the road must exert a total forward force of 51.175 Newton on the bike to keep the cyclist moving smoothly up the 5% slope at 27 km per hour.
The conclusion for question 2 Roman, we need to solve two problems of the bicycles. First, we need to find the work done, and the second is find the power. First, we use W equal to F multiplied by D. Use F in 1 Roman, D equal to 1200 meters. W equal to 51.175 multiplied by 1200 equal to 61,410 joules. For the second part, we use formula P equal to W over T. For T, we use formula P equal to D over V. Use V equal to 7.5 meters per second. So, T equal to 1200 per 7.5 equal to 160. So, T equal to 61,410 divided by 160 equal to 383.8125 watt. For conclusion, this case study shows that the gravity significantly affects bicycle motion slope. When cycling uphill, the cyclist must exert additional force to overcome the component of weight acting down the slope. In contrast, the gravity helps to accelerate the bicycle downhill, reducing the effort required. Therefore, uphill cycling is more difficult than downhill cycling because it takes more time and power to cycling until top of the hill.